Hello guys, welcome back to the channel Mathemagix JEE. This is part of the CBQ series or the concept building question series where we are going to solve specific problems to build our problem solving approach for JEE Advanced. As always, you should attempt this problem yourself before seeing the discussion. So let's begin our discussion. It says in a two-dimensional plane, the Cartesian coordinates of points P, Q, R, and S are given as 4, 4, 6, 6, 4, 8, and 2, 6 respectively. Okay. So let us understand the given situation. Let us understand this by a diagram. So we are going to draw a diagram here. Let's say this is our axis and PQRS are 4 points given to us 4, 4, 6, 6 and 4, 8 and 2, 6. Okay. So here let's say it is 4, 4 and it is 6, 6. Okay. So somewhere here this is 4, 8 and 2, 6. So 4, 8 will be here and this 2, 6 will be here. So basically this is a square. Let us draw this square first. So the square is like this, lying on xy plane, and this is the vertex 2, 6, and here it is 4, 8. And what is the length of the side? This length, the length of the diagonal, it is how much? It is 4 units. So it will be 4 divided by root 2. So 2 root. Now it says let A denotes the region bounded by points P, Q, R, and S. Okay. So A is this region, this total region, and B denotes the part of the region A for which any point L taken in region B is such that distance of L from nearest diagonal of region A is less than distance of L from any of the sides of region A. Okay, so it's a long statement. Let us decode this word by word. So it says any point L taken in region B is such that distance of L from nearest diagonal of region A. Okay, so basically we are talking about the diagonals of this square. So let us draw the diagonals clearly here. These are the diagonals of this square. Now it says distance of L. L is what? L is a randomly chosen point in this region B is such that distance of L from nearest diagonal of region A is less than distance of L from any of the sides of the region A. Basically, we should name the vertices first here. So 4, 4, 6, 6, 4, 8 and 2, 6. Okay, so this is P, this is Q, this is R and this is S. So basically Q, S and P, R are the two diagonals. Now this question says about some inequality. What is this inequality? It says that a random chosen point L in this region B, the distance of this point L from nearest diagonal is less than distance of L from any of the sides of region A. Any of the sides. So let us first understand the situation. Let's say we choose a point here in this region. So let us choose this point. So we can say for this point, it is one of the points L. Its nearest diagonal in this case will be PR, and its nearest side will be this QR, and this point's distance from this PR must be less than its distance from any of the sides. That means its distance from these four sides can be represented as this perpendicular distances, like this. And what is the perpendicular distance of this point from this diagonal? This is this. Now think carefully about this, that if we want to apply this inequality, that distance of L from nearest diagonal is less than distance of L from any of the sides. That means we only have to consider the case that the distance of this point from this PR diagonal is less than the minimum distance of this point L from any of the sides. Now, what is the minimum distance of this point L from any of the sides? This is this distance. Here we can sketch this. This is this distance. So let's say this is LM. So we can say this. Let's say this point is we say N. Then LN is less than LM. As we know, this square is symmetric about all its diagonals. So we can only consider this region and calculate the mirror image about this diagonal and this diagonal to get the total region. So let us first consider this, only this region here, only this quadrant. So ln is less than lm. Now how to sketch this region? Let us first focus on the corresponding equality. What will be the corresponding equality? Ln equal to Lm. So Ln equal to Lm, if we draw the diagram here, let's say this is our R, P, and this is our Q, and this is the randomly chosen point M, sorry, L. So L will lie on this curve if this here, this line is the angle bisector of this PRQ angle. So we can say by the concept of angle bisector, we can say from any point on this angle bisector, the distance, perpendicular distance of these two lines will be same. So this is the curve ln equal to lm. Now we can say clearly this region here will correspond to this ln is less than ln, and this region will correspond to ln greater than ln. Now think about this, that we only considered this case when L is this point. That means if we take the L point somewhere here, let's say, then the nearest diagonal will change. Why? Because in that case, our nearest diagonal will be this. So we have to consider this and this line. So like this. So if this is the boundary here, ln equal to lm, then in this case also there should be this boundary, which is again ln equal to lm, like this. And our region will be simply the union of these two. That means this region with this boundaries here. Now we can get the total region B by reflecting this region about this diagonal and this diagonal. So we get our total region here. Let's say this is our given square. Okay, it is looking like diamond. I should draw it a bit clearer. let's say this is our given square. So our region will be simply, if this is the diagonal PR and this is the diagonal QS, then this is our region. So this is the region D, and this total region is our given A region. So now we have to find what the probability that a random selected point on Cartesian plane lies in region B if it is given that it lies in region A is this. Okay. So the first two options are saying that we have to find the probability that a randomly selected point on xy plane lies in region B if it's given that this point lies in region A. Okay. So the probability will be simply probability of point lying in this region B divided by probability of this point lying in region A. Now, whenever we are talking about some region, basically geometrical probability is what we need to consider. So, we can say this will be simply area of B divided by area of A. Now, what is the area of B? Area of A is simply we can determine because this side length here is 2 root 2. So, area of A can be written as 2 root 2 whole square. That is not the problem. But the area of B is what we have to find. So, let's discuss this region again, this single region here in detail. So, this, if we name the vertices, it will be R and Q. And let's say this point is O. So O, R and Q. So here this is our angle bisector and this is our angle bisector. They intersect at this point. So now this angle is same as this and this angle is same as this. So now we can say by the symmetry of this region that this line will be perpendicular to this line QR. So let's say it is uh, OG. Then OG is perpendicular to QR and this is the perpendicular bisector of this QR line. So this distance will be 2 root 2 by 2. So root 2. And this distance is basically half of the length of the diagonal. And length of the diagonal is 4 units. So it will be 2 units. Now we know that the angle bisector of an angle bisects the opposite side in the ratio of the adjacent sides. So if this ratio is root 2 is to 2, then it should be also root 2 is to 2. This length is to this length. Sorry, 2 is to root 2 because we are taking this length first and then this length. So let us say this is 2k and this is root 2k. So let's say this point is H, OHG. So OH is to HG is equal to 2 is to root 2, which is root 2 is to 1. Now the total length of this OG line will be half of the side length of this square. Why? Because this line is parallel to either of this side or this side. So OG is half of the side length. So half of side length is 2 root 2. That means it becomes root 2. So now we can easily find the length HG. Why are we interested to find the length of HG? Because then we can easily calculate the area of this triangle HQR like this. So our area of B can be written as this total area of A minus 4 times area of this HQR. This we can substitute here and find the probability. So Hg is 1 divided by root 2 plus 1 times root 2. So root 2 divided by root 2 plus 1. Now this delta HQR, which is the area of this HQR triangle, will be half times base into height. Base is 2 root 2 into height is this Hg. So root 2 divided by root 2 plus 1. That means it will become 2 by root 2 plus 1. So area of B becomes area of A is what? 2 root 2 whole square minus this 4 times this area. So 4 times 2 is 8 divided by root 2 plus 1. This, if we calculate, it will become P equal to, this is area of B can be written as 2 root 2 whole square. So 2 root 2 whole square minus 8 divided by root 2 plus 1 and divided by 2 root 2 whole square. So it will be 1 minus 8 divided by 2 root 2 whole square is basically 8 divided by 8. So 1. So this comes out to be root 2 divided by root 2 plus 1. That means our desired probability in this case will be this much. So option A is correct and option B is wrong. Now we have to check option C and D. Option C and D are basically similar. They ask for the number of elements in set M equal to x comma y such that x and y are integers and xy belongs to the region T. So what is T? T is a set formed by Cartesian coordinates of all the possible points lying in region B. Okay. So basically we have to find the number of points of integer coordinates lying in region B. So this is our aim. So let us sketch this region again here. So I am sketching only the region B. This is shaped like a star. So this is this. And let us mark these vertices also. So these are 4 comma 8, 4 comma 4. This is 2 comma 6. This is 6 comma 6. Now how to find the number of points of integer coordinates lying in this region. So if we find the points of intersection of these two diagonals here, it will be this. This is the point 4 comma 6 and the coordinates of these points are integers. That means this is a desired point. Now let us find other points if possible. So we can clearly see that as the point 5 comma 6 lies on this line, so this will also fall inside region B. So this is also a desired point. And similarly, the reflection of this here will be this. This will be the point 3 comma 6 and this is the point 5 comma 6. Similarly, here we will get the 2 points 4 comma 7 and 4 comma, this will be 5. So we can get total 5 points in this region B whose coordinates are perfect integers. So there are 5 points. The number of elements in set M are 5 where T is a set. Okay. So we can say clearly this option C will be correct and option D will be wrong. That means our final answer in this case will become A comma C. So A and C are the correct options of this question. I hope you understood the concept behind this problem. I have also brought a similar type of question for you guys. You attempt this yourself and post the answer in the comments.